All right, so in 1.6, we are solving algebraic equations for a variable. What this means is that you're going to see multiple variables in an equation, and they're going to ask you, for example, solve for x. That would just mean to get x all by itself. If they ask you to solve for y, that would mean to get y by itself. If they ask you to solve for w, that would mean to get w all by itself. So to isolate a variable, you typically want to perform inverse operations in reverse order, right? If I see plus, I want to do minus. If I see times, I want to do divide, right? Inverse operations. And then if I see that acting on a variable, we have multiplication and then addition in that order, I would want to reverse the order by using subtraction and division, okay? In general, the easiest way to think about this is just to follow your rules of solving equations, okay? My rules of solving equations are as follows. I need to add or subtract once on each side. So if I'm going to add 5 to the left, then I add 5 to the right. 5 on the left, 5 on the right. If I need to subtract, I would subtract 5 on the left and 5 on the right. Okay, I gotta keep it balanced though. The other rule is I want to multiply or divide every term. So if I want to get rid of this 3 and I divide this 3x by 3, then I have to divide this term by 3 and I have to divide this term by 3. Because when you divide a whole side by a number, you're dividing every term by that number as well. So I'm going to show you two different ways to do this. First way and a second way. The first way, well, if I'm trying to solve for x, that means that I want this x all by itself. So I'm going to have to move this 3 at some point. I'm going to have to move this y over 4 at some point. So one thing I could do is if I have 3x plus y over 4 equals 2, I could go ahead and I could use inverse operations. So I'm going to go ahead and subtract y over 4. All right, because the opposite of plus y over 4 is minus y over 4. These will cancel, and now my new equation is 3x equals 2 minus y over 4. And then I see that still acting on the x is a times 3. So instead of times 3, I'm going to divide everything by 3. And again, if I divide this side by 3, I have to divide every term by 3. So the 3's cancel, and we end up with x equals 2/3 minus y over 12. Okay, so that's going to be our answer. Now, if we do it this other way, we should get the same answer. Let's check it out. We're going to go ahead and we are going to take my equation, 3x plus y over 4 equals 2. And let's actually do it reverse. Let's try to divide everything by 3 first. So if I divide everything by 3, we end up with x equals y over 12. Sorry, that was a plus symbol. X plus y over 12 equals 2/3. And then my last step is just to move this y over 12 over to the right side, so we can use some subtraction. All right, cancels on the left. And again, that leaves me with x equals 2/3 minus y over 12. And you should notice that we do, in fact, get the same answer. All right, so again, as long as you follow these rules, it's really hard to make a mistake unless you make some sort of arithmetic error. All right, now we've got the same problem, but we are asked to solve for y this time. All right, we're again going to try this 2 different ways. All right, following my rule. So if I'm trying to get this y by itself, I see, first thing, maybe I could just move this 3x over to the right side to get it away from the letter y. So what I'm going to do is I'm going to take my 3x plus y over 4 equals 2, and I'm going to go ahead and I'm going to subtract that 3x on both sides. And it cancels on the left, giving us y over 4 equals 2 minus 3x. And then we're going to go ahead, and I see that y is being divided by 4. Well, the opposite of divide by 4 is times 4. So I'm going to multiply the first term on the left by 4, and I'm going to multiply this entire side by 4, right? This 4 has to go to the 2, and it has to go to this minus 3x. All right. So on the left side, the 4's cancel, so we just end up with y. 4 times 2 is 8. 3x times 4 is 12. And there we go. We've isolated the letter y. Next, excuse me, sorry. Next what we're going to do is we're going to do it a different way. We see that y is being divided by 4. So since y is being divided by 4, we can multiply every term by 4. All right, so we're going to go ahead and take my 3x plus y over 4 equals 2. And we're going to multiply the entire left side by 4. Again, this gets distributed to every term, and then we'll multiply the right side by 4. So my new equation is 12x plus y, because again, 4 on top, 4 on bottom, that's going to cancel. That's going to equal 8. And then we just have to move this 12x over away from the letter y. And when we do that by subtracting minus 12x minus 12x, we see that they cancel on the left, and we end up with y being isolated, 8 minus 12x. Notice it's the same way, however you want to do it, not going to make a difference. Next one. Here we're trying to solve for x. All right, so in general, whenever you see x in the denominator, it's a good idea to try to get x out of the denominator. So what I'm going to go ahead and do is I'm going to multiply everything by x. So m over x plus h equals w. I'm going to go ahead and multiply the term on the left by x, the h by x, and the w by x. Right? Everything gets multiplied by x. Cross out the x's, and now we find out that plus xh equals xw, or wx, however you want to do that. So now I've got two x's, which is kind of weird, but what I can always do is go ahead and try to combine them. So I'm going to move that xh over to the right side. So I want to get my x's on the same side right now. And this is now going to give me m equals xw minus xh. All right, it looks a little bit better because we're trying to solve for x, and now we at least have x on the same side. The nice thing here is that we can do what we call factoring, right? We've learned factoring a while ago, so we know that if I look at m equals, and I look at these two terms here, I can see they both have an x in common. So I'm going to factor out an x and see what I have remaining. Well, x times w is xw, and x times negative h is negative xh. So this is very close to my final answer. What I can now do is I see that x is being multiplied by w minus h. So to get rid of that w minus h, I'm going to go ahead and divide both sides by w minus h. And this is a big piece of the puzzle because now they cancel, and we can see that m over w minus h is x. All right, so that's going to be how you isolate x there. One more similar problem, notice the similarities here. Again, we're solving for x, so I'm going to go ahead and take this and I'm going to try to get it out of the denominator. So I'm going to go ahead and multiply both sides by x. And these x's cancel. Now we're just left with m plus h equals wx. And at this point, I'm going to try to get rid of this w because then I'm done. So if we divide both sides by w, they cancel now, and we've got x equals m plus h over w. There you go. So again, the key thing with this is just your rules, right? If you're going to add or subtract, do it once on each side. Once on the left side of the equal sign, once on the right side of the equal sign. If you're going to multiply or divide, you have to multiply or divide by every single term to keep it balanced, right? And that's about it for 1.6.